a variable. Okay, I'm going to make this spin again here. Okay, so examples would include the absolute value of x minus 3 equals 7. You see there's no y anymore. We're actually solving. 2 absolute value x plus 6 plus 12 equals negative 4. Then we have some quadratics. Okay, so here's the steps on how to do this. When solving an absolute value equation, you first have to isolate the absolute value. Then you need to consider two cases. Because remember, what's the definition of an absolute value again? It's two cases. What was it? X, positive x when x is greater than or equal to 0, and negative x when x is less than 0, yes? So that's case 1. The expression inside is positive or equal to 0. That's this one, right? Case 2, the expression inside is negative. That would be that one, okay? And the key here, as a lot of the ones that we're solving, is you need to check your answers, as some absolute value equations have extraneous roots. And remember what that was? Answers that don't work. So you get a solution, you think all is good, and then you sub it back in and it doesn't make sense, right? So let's start with some easy ones. If the absolute value of x equals 10, I bet you could tell me what x is. But we're going to actually do the steps like you would do for all of them. So in order to actually get rid of the absolute value, you need to split it into two cases. You have to have the positive inside, which would be just x in this case, and the negative inside, which would be negative x in this case. And of course, it equals 10. So do you see I'm getting actually two equations, which means I'm going to get two solutions. So the one on the left automatically is solved. That's pretty easy. The one on the right, what would I do to solve this one? Yeah, switch the signs. So my solution would be those two answers. Like I said, you probably could just look at it and tell me it would be 10 and negative 10, right? Okay, so let's do the next one. Again, in order to get rid of the absolute value sign, we need to split it into two cases. First case, the inside is positive, and second case, the x is negative. Not just the x. So here's where it's the inside expression. So negative, the whole thing. I'm going to use brackets. Okay? Now, this is true when you might say x is greater than or equal to 0, but it's not. It's when the inside is greater than or equal to 0. So this is when this equals 7 when x minus 3 is greater than or equal to 0. I'm not giving myself enough room. Let me just erase this a little bit more and move this over. Sorry. So this is negative. Whoops. Negative x minus 3 equals 7. So again, this is true when x minus 3 is greater than or equal to 0. Does everybody see that? So now, this is only true. Can we solve for an inequality? Move the 3 over. What do we get? X is greater than or equal to 3. We learned that in grade 9. We probably did a little bit more in grade 10, but do you remember how to solve? It's just like an equal sign. The only thing you have to watch out for is what? Yes, if you're multiplying or dividing by a negative number to both sides, you have to switch the inequality sign. So if it was a less sign, it becomes a greater than. Okay. So, how do I solve this? Move the 3 over. We get x is equal to 10. Look at my inequality. Is that okay? Yeah. X is 10. It's greater than 3. It works. Yes? Okay. So now here, this one is when x minus 3 is less than 0. Again, where am I getting this stuff from? From the definition. Whatever's in the inside, like I can make this a happy face or a red blob. It's equal to the red blob when the red blob is greater than equal to 0, or negative red blob when the red blob is less than 0. I guess what I'm trying to say here is it's not just X, it's whatever's inside, right? So now it's the red blob. So, does everybody see? Here's the red blob, right? X minus 3 is the red blob. So that's when x minus 3 is greater than or equal to 0, or when x minus 3 is less than 0. Yes? Okay. So now, if I solve that, x is less than 3 then, right? Okay. So, negative x plus 3 equals 7. Does everybody see how I got that? I distributed that negative that was in front of the brackets. Move the 3 over, I get negative x equals 4. Is that true? And then, how do I get the last step? Switch the signs. X equals negative 4. Is that less than 3? Yes, then that restriction makes sure that my answer is 1. Okay? And in the end, it's algebra. You can sub in negative 4 and see if it works. Does negative 4 minus 3, that's negative 7. Absolute value negative 7, is that 7? Yes, it works. Plug those both in, see if it works, right? Yes? Okay, let's go. Next one. The absolute value of 2x minus 5 minus 7 equals negative 3. So, we're going to split into, maybe I'll just write it out as case 1 and case 2 over here. Make sure you get 2 cases. If you only do 1 case on the test, you'd only get maximum 50% because you're only doing half the thing, right? Make sense to you? Okay, so this equals 2x minus 5 minus 7 equals negative 3. And case 2 is negative bracket 2x minus 5 minus 7 equals negative 3. Actually, I was supposed to actually get the absolute value by itself first. So maybe I should actually do what my steps say and do that first. Just because I know it's going to get more complicated than that. I know you're all going to complain here. Move this 7 over. Then you get absolute value of 2x minus 5 equals what? 4. So in this case, 2x minus 5 equals 4. And in this case, negative 2x minus 5 equals 4. Does everybody see what I did? Okay. Get the absolute value by itself first. It's just easier. Then you're not switching all the signs on the left-hand side. That's where I'd see you making a mistake. Okay, when is this true? When 2x minus 5 is greater than or equal to 0. So, what does that mean? Move the 5 over, divide by 2. X has to be greater than 5 over 2. Yes? Am I doing that too fast? How about this one? This is true when 2x minus 5 is less than 0. Well, x has to be less than 5 over 2 here. It's going to be the same number each time, right? It's just one's a negative, sorry, one's a less than and one's a greater than. Yeah? Okay, let's solve this. Move the 5 over, we get 2x equals 9. X equals 9 over 2. Is that greater than or equal to 5? Yes? Okay, what do I have to do first here? Distribute that negative, so negative 2x plus 5 equals 4. Negative 2x equals negative 1. Is that good? So x equals 1/2. Is 1/2 less than 5 over 2? Yes. And you might say, isn't it always going to work out? No. Okay. No. Pretty good so far? Okay. Isolate this absolute value, so we got to move the 12 over, so we get absolute value of 3x minus 4 is equal to negative 3. Yes? Okay, now we're going to do case 1. That would be 3x minus 4 equals negative 3. And that's when 3x minus 4 is greater than or equal to 0. Everybody see where I'm getting this from? The red blob, yeah. So move the 4 over, divide by 3, we get x is greater than or equal to 4 over 3. Case 2, negative bracket 3x minus 4 is equal to negative 3. And then that would be when x is less than 4 over 3. By the way, on the test, I will make a space for you to put that restriction. Show you two cases, yeah? That might also help you realize you have to split it into two cases. Okay, so if I move this over, I get 3x equals 1, and x is equal to 1 over 3. Is that true? No. So what am I going to do now? Reject. Don't scribble. Reject. Okay, what am I going to do over here? Negative 3x plus 4 equals negative 3. Move the 4 over, I get negative 3x equals negative 7. Divide by negative 3, I get x equals 7 over 3 positive. Is that true? Nope. Reject. So what's my answer? No solution. Okay, now, did anybody actually come into play here that I could have told this right from the very get-go? Yes. Oh, Brandon did. Oh, I thought you were saying, yeah, I knew that there was going to be no solution. Okay, think about my first thing up here and why I would say I should have known from the very get-go that this would be no solution. Yes? Yeah, this can never happen. You can't have an absolute value equal to a negative number, right? Yeah. So at this point, I could have went directly to no solution. But this is another reason why your restrictions are huge, right? Okay. Yep. Yep. Good question. The question was, if I went directly to no solution and not show all that steps, would I get full marks? For sure. Example 3. You see now this is getting a little bit more complicated? Yes? Okay. So, we got to isolate the absolute value. It's already isolated for us, right? So now we can go directly into cases. Case 1. 2x minus 5 equals 5 minus 3x. I'll leave a space. Case 2. Negative bracket 2x minus 5 equals 5 minus 3x. And what's the restriction here? Well, 2x minus 5 has to be greater than or equal to 0. Does everybody see that? So now if I move the 5 over, divide by 2, what do I get? X has to be greater than or equal to 5 over 2. And what would this restriction be then? X has to be less than 5 over 2. It's not like you have to solve it twice. You know it's going to be the same thing except just the different inequality sign. Okay, so we know how to solve this one here, right? Move the x's to one side, the constants to another side. So I move the negative 3x over, I get 5x. If I move the minus 5 over, I get, what do I get? 10. So what does x equal? 2. Is that true? Is 2 greater than, what is 5 over 2? It's 2.5, so we would reject this. Does everybody see? Just for fun, substitute 2 in there. You get 2 times 2 is 4. 4 minus 5 is negative 1. Absolute value of negative 1 is just 1. So the left-hand side gives me 1. If I put 2 in there, I get 3 times 2 is 6. 5 minus 6 is minus 1. I have positive 1 equal to negative 1. Do you see why we're rejecting it? Okay, moving on to the other one. Negative 2x plus 5 equals 5 minus 3x. Again, move the x's to one side, the constants to the other. If I move the negative 3x over to the other side, I get positive x. If I move the positive 5 over to the other side by subtracting 5, I get x equals 0. Is that true? Yeah. Again, just for fun, you can substitute it in because algebra guarantees you 100%, right? Sub it in, you get the absolute value of negative 5, which is 5, and this goes 5 equals 5. So my only solution is x equals 0 in this case. Okay, are we good? Okay, moving on. We are going to solve x squared, the absolute value of x squared minus 2x equals 1 algebraically. So forget about the graphing right now. Let's do the same steps we just did with those linear absolute values, but do it with a quadratic. So isolate the absolute value. It's done. So that means we go into two cases. Case 1, x squared minus 2x equals 1. And case 2, x squared, sorry, I need a negative in there. Negative bracket x squared minus 2x equals 1. Okay, so how do I solve a quadratic? Yes, remember we learned this a couple units ago or so. Solving quadratics, you have three methods. The fastest, most easiest way is factoring. Probably the second most is quadratic formula. And that's only if it doesn't factor, and then completing the square. So in order to solve any of them, you need to equal to 0 first. So we get x squared minus 2x minus 1 equals 0. Does this factor? Okay, so if you're not sure, what was the trick to tell whether it factors or not? Do the discriminant. And if the discriminant is a perfect square, then we know it could have been factored. And if it's not a perfect square, but it's still positive, then we keep going on our merry little way with the quadratic formula. What happens if it's negative? Then it doesn't have any solutions, right? So let's check. B squared minus 4AC. What's my B? Negative 2. So negative 2, the whole thing squared, minus 4 times 1 times negative 1. So I get 4 plus 4, which is 8. So what does that mean? It can't be factored. 8 is not a perfect square. However, we've done half of the quadratic formula now. We just keep on going to solve. So x equals minus b. So minus minus 2 is 2, plus or minus the square root of the discriminant, which was 8, all over 2a, so all over 2. Does everybody see that? What's wrong? Okay, next one. Negative x squared plus 2x equals 1. This time I'm going to move the x. I would never try to factor anything that has a negative x squared. So I'm going to move it over to the right-hand side so it's all positive. So I get 0 equals x squared minus 2x plus 1. Does this factor? Yeah, it does. 0 equals x minus 1 times x minus 1. So that means x equals 1. Okay, and you might say, well, but you didn't do the restrictions here. So we're going to graph these just so I can show you some stuff. So the problem is do you know how to graph that? You should. Yeah, we just did this. So how would you graph y equals the absolute value of x squared minus 2x? Well, you would graph the inside, right? So how would I graph that? let's call it y, whatever. Who cares if it's the same y, but like, how would you graph x squared minus 2x? How would you graph that parabola? I'm sorry? Well, in order to graph a parabola, we know it's opening up, right? It's not stretched, but how am I going to get the vertex if it's shifted over or anything like that? We need to complete the square. So what's half of minus 2? Minus 1 squared is plus 1. In order to plus 1, I can't just do that. I have to minus 1. So there it is. X minus 1 minus 1. So what does that mean? It's a parabola that got shifted. Right one, down one. And then I have that base one like this. 1, 1, 2, 4. 1, 2, 3, 4. Okay, and then what I went over today with the daily quiz was what happens? The part underneath gets reflected. So this now becomes here, and it looks like that. Yes? And I erase. Is everybody good with how I got that absolute value parabola? Okay, now it says to also graph g of x equals 1. How do I graph g of x equals 1? Huh? How do you graph this? Nobody knows. Which way is the line going? Vertically? It's a constant function. That means it doesn't change. It goes straight across. Straight across where? At 1. Looks like that. So this is g of x equals 1. This is f of x equals the absolute value of x squared minus 2x. What do we notice? It intersects uno, dos, tres, 3 times, right? How many solutions do I have there? I only have 2? Really? I have 3, because what does this quadratic formula do? Yes, this actually splits in what is 2 plus root 8 over 2 and 2 minus root 8 over 2. In this case, I'd probably take a calculator to get a decimal equivalent, but I guess it's probably about negative, what? That one's probably giving you negative point something, 0.6. And this one's giving you positive 2 point something. And what is this giving you? 1? Yeah? Sure. Okay. Let's solve this. Oh, by the way, until I do the next unit, you wouldn't be able to get the restrictions for a quadratic. That's why I showed it to you that way. Okay. The restrictions will be for the linear only, and for the quadratics, you'll have to check your answer. So, do you guys want to try 6 and 7? Yes, try it. So x minus 10 equals x squared minus 10x when x minus 10 is greater than or equal to 0, which means x is greater than or equal to 10. That's case 1. Case 2. Negative bracket x minus 10 equals x squared minus 10x, and that's when x is less than 10. So move everything over. 0 equals x squared minus 11x plus 10. So that factors beautifully. So x equals 10 and 1. And I will now reject 1 because it's not greater than or equal to 10. This one is negative x plus 10 equals x squared minus 10x. 0 equals x squared minus 9x minus 10. Yes, this, again, factors beautifully. Beautifully. X equals 10 and minus 1. Check. I need to reject 10. So what's my solution? X equals 10 and minus 1. Remember when I said the definition of the absolute value, it doesn't matter where you put the equal sign? So in this case, if you would have put the equal sign on this side, you would have kept 10, but then you would have rejected both of them over here. Either way, you're going to get 10 and negative 1. Okay, have we had a chance to do example 7? Yeah? Okay, case 1. And if you want, you can go on to example 8. Case 1. X minus 5 equals x squared minus 8x plus 15. And that is when x minus 5 is greater than or equal to 0. So x has to be greater than or equal to 5. Case 2. Negative bracket x minus 5 equals x squared minus 8x plus 15. And that's when x is less than 5. 0 equals x squared minus 9x plus 20. Oh, this factors beautifully. So x equals 4 and 5. Am I going to reject any? Yep, I'm going to reject the 4. It has to be greater than or equal to 5, right? Negative x plus 5 equals x squared minus 8x plus 15. 0 equals x squared minus 7x plus 10. Oh, that factors beautifully. X minus 2, x minus 5, x equals 2 and 5. Which one do I reject? 5. Whoop, 5. So, what does x equal? 5 and 2. And again, you can substitute it back in and see if it works. Just to make sure. That's how you're going to get 100% on this test, right? Yeah? It's possible. Okay, moving on. So we have two cases. Again, the restrictions might not be easy to do for a quadratic, so we're going to check our answers instead. Until we do the next unit on how to solve an inequality with a parabola. I can show you it right now if you want, but I don't know if I want to. So anyways, next, negative x squared plus 2x plus 8 equals 5. And case 2 is negative bracket negative x squared plus 2x plus 8 equals 5. There is restrictions. We just don't know how to solve it quite yet. So we're going to check our solutions to make sure. So in order to solve this, we need to make sure everything's equal to 0. But because it's a negative x squared, I'm going to move everything over to the right-hand side. 0 equals x squared minus 2x minus 3. Why do I do that? Because it's just craziness to try to factor a negative x squared. 0 equals, what, x minus 3x plus 1? So x equals 3 and negative 1. Okay, so we're just going to test that in a second here. So I'm going to switch all the signs. So I get x squared minus 2x minus 8 equals 5. Is everybody good with that? So now I'm going to move the 5 over. X squared minus 2x minus 13 equals 0. So it doesn't factor. 13, it's prime. So now we need to do b squared minus 4ac. Why do I do b squared minus 4ac instead of the whole entire quadratic formula? Because it could be negative and there's no point, right? Okay, so b squared would be minus 2 squared minus 4 times 1 times negative 13. So I get 4 plus 52. 57. That means we have to go on, unfortunately. 56. Thank you. Okay, so x equals minus b. Minus minus 2. 2 plus or minus the square root of 56. All over 2a, 2. And you might say, how am I going to do this now? Well, the only way I can check it with the quadratic is with the calculator, so we'll grab the calculator and put her in. First off, let's check this one. If I put 3 in and I square it, I get what? 9 with a negative. So I get absolute value of negative 9. I put 3 in there, I get plus 6 plus 8. Will I get 5? I will. So that worked. Now I'm going to put negative 1 in there. If I square negative 1, I get 1, but then I still have a negative. So negative 1, if I put negative 1 there, minus 2 plus 8, does that equal 5? Yep, so that one works. Okay, over here. Do you want me to show my calculator here? Because some of you might not know how to do this, hey? Okay. Hold on, I'm going to just pause this to get my calculator. So I'm going to do, I'm just going to move this up and over a little bit. So this is going to be, do you know with the graphing calculator you actually have absolute value signs? Yeah, this is special. If you go to number, there's number 1 is absolute value. So if you have absolute value, then it's going to be, this might be too much to punch in all at once, but anyways, it's negative. Make sure you're using negative. And then you're going to use a bracket now. So the bracket's going to be this quadratic formula thingy. So now, in order to do 2 plus or minus square root of 56, you need another bracket. So bracket 2 plus square root of 56, you got to end that square root. You got to end the top part divided by 2. And then you got to close that bracket and square it. And then what else does it say to do? Plus 2x. So plus 2. Now we got to do the quadratic formula yuckiness. So again, an extra bracket for the top. So 2 plus the square root of 56. And you might be saying, on the test, are you going to make me do this? Again, I'll be nice enough that, well, perhaps we'll have one that is factorable. However, you should still get used to doing stuff like this. Divided by 2, of course. And then I got to close that bracket. So I have a bracket here, now I got to close the bracket. And then plus 8. Plus 8, and I got to close the absolute value bracket. Okay, so I get 5. Hey, look at that. I get 5. So you should get 5. That's what it's supposed to be. 5 over here. Okay, now I'll show you the beautiful thing about this graphing calculator. You think, oh, now I have to punch it all in again. No, you don't. Whoa. You don't. What's going on here? You just go second enter, and then all you have to do is change that plus square root into a minus square root. So I'm going to go up there and go subtract and go up there and go subtract and go enter, and hey, it looks like it's a 5 again. So all 4 solutions work. All 4 solutions work. What do you mean, what are the other 2 solutions? This and this. If I were to do a quick sketch, I'm just going to do an absolute quick sketch. It's not even going to be anything beautiful. Who can tell me what this parabola looks like? It's a parabola that's, yes, like this. But if it's an absolute value, what would it really be? that part would be like this, yes? And the constant function y equals 5 is probably somewhere here. So do you see how I get 1, 2, 3, 4 solutions? Yeah.